Dr. Clif Kussmaul, Principal Consultant at Green Mango Associates, LLC, and former Associate Professor of Computer Science, Muhlenberg College, USA. Dr. Clif is Principal Consultant at Green Mango Associate, LLC. He is former Associate Professor of Computer Science, Muhlenberg College, USA. And his PhD is from University of California, Davis. He has authored more than 100 peer-reviewed articles, chapters, and conference presentations. He has conducted more than 100 workshops and special sessions at global conferences and institutions. He has secured funding from the US National Science Foundation, the Whittle, the Prize Competition, Google, and others. He is a Fulbright specialist at Fulbright University, Vietnam, and Ashesi University, Ghana. He is also Fulbright Nehru Scholar at University of Kerala, India. I welcome Dr. Clif Kussmaul to deliver his lecture.
Hello, everyone. How are you? A bit sleepy after lunch? So, I want to talk to you a bit about education and innovation and how they're connected. I will ask you some questions, have you do some thinking and talking. If I'm a teacher and I don't listen to the learners, I'm not doing a very good job of teaching. So I want to learn from you just as I hope you will learn something from me, okay? So we've heard several keynotes today talking about all of the opportunities that are ahead of us. Many different technologies that could make the next 50 years change as much as the last 50 years have changed. So people talk about additive manufacturing, virtual reality, blockchain, generative AI, all of these different technologies, and we can't even imagine how they will change the way we live, the way we work, what the world is like. That's very exciting, I think, especially for students that are at the beginning of this journey. You could be part of some really amazing things. I think that's great. But there's a big problem. We don't have enough people to develop these technologies and make them happen. We don't have enough engineers. We don't have enough computer scientists. We really need many more people coming into these careers. My wife is a structural engineer, civil engineering, same problem. There aren't enough people trained to do the work that needs to be done. There was an article in the Hindu just a few months ago. According to an economic survey, 51% of the youth of India are not employable. Or 51% are employable, 49% are not employable. The good news is that's much better than it was maybe 10 years back. People are graduating from universities with degrees and not able to get jobs. I talk to people in industry, I hear the same thing. These freshers need much more training. They're not ready to do the work we need them to do. So, I want you to think for 1 minute and then talk to the person next to you for just 1 or 2 minutes. Why is this problem happening? What's the gap? What needs to be fixed for this to be better? Okay, so think for 1 minute, talk for 2 minutes. I'll ask a few people to share their ideas. Go. You didn't know there was going to be homework, did you? Okay, I'd like to hear some of the ideas that you have, some of the ideas that you've shared with your neighbor. Lack of skills. Lack of what kind of skills? So a lack of technical skills? Technical skills, okay, good, thank you. What else? Yes, so the learning environment and the work environment are very different, not just the physical space, but the way you're expected to behave, the way you're expected to meet deadlines, the way you're expected to interact. Good, thank you. I've heard from 2 boys. In my experience, the girls are usually at least as smart as the boys. Well, so this is one gap. If I hire engineers, I expect them to ask questions, to raise doubts, to share ideas. If I hire an engineer and they just sit at their desk and wait for me to tell them exactly what to do, I will find a different engineer. One idea. You can say your friend said it, so it's not your idea. Anyone else?
Problems which are either so-called solved examples within the text, or maybe even unsolved problems at the end of the chapters, which are largely based on what is taught in that chapter. But often the education system doesn't tell us how to attempt to solve problems which you didn't even see before, or even worse, that how to kind of create a problem, how to create something new, so that you can actually solve a problem which was not even thought about it, and probably you will be finding a solution for it too. So in other hand, in other terms, what I said is we teach sort of problem solving techniques, but we don't teach the methodology to solve an unknown problems, which we usually face the moment we get into a job space, right? So, and most of the time, we take a lot of time to even become useful to the organization, because we always face unknown problems when we
Yes.
figure it out.
Thank you. So in school, we mostly learn to solve small problems that are connected to the chapter. And most real problems are big, they're messy, there's some technology, but there also is some business issues and some customer issues and some getting people to talk to each other issues that are much, much bigger, much messier than the problems we often see in school. Those are the problems that are most important to be able to solve. The people that get paid lots of money, the people that get promoted to important roles are the people that can solve those messy problems. One more person?
Yeah. So basically, I feel, there are a lot of skills gap is there between industry and academia. One is all projects that they do are simulation based. So they don't know the real issues. They don't know the creativity, analyzing, problem solving skills are missing, which are very important for any industry. So basically that needs hands-on experience. And technical foundation is also, I could see a lot of missing because attentiveness is missing among the students listening to the teachers and professors. It is a true fact, I feel. And no proactive approach to learn the things.
Good, thank you. So I think we could have an interesting debate. Is the problem that the students are not attentive enough and not working hard enough? Or is the problem that the teachers are maybe not teaching the right things in the right way? We can discuss that in a bit. So here's some more data. Whoops, the formatting's... So every year there's a survey of employers in the US. I'm sorry, the numbers are a little bit, the formatting got screwed up. What are the skills they most want to see in new graduates? What are the top skills? Problem solving, work in teams, work ethic, analytical quantitative, communication, leadership, communication, flexibility. These are the skills that employers say they want that they often do not see from freshers, from new graduates. This same organization has been doing this survey for 20 years. The numbers don't change that much. I would bet money if we did that survey in India, we see very similar results. So here's a question. These are all important skills. Where do students learn those skills? Students, are you taught these skills in the classroom? Are you taught problem solving, leadership, teamwork, communication? Yes? No? Mostly it's outside of class. So the professor says, here's a team project, learn how to work as a team. Teachers, how much time in your class do you spend teaching these skills? Do you teach problem solving? Do you teach teamwork? Do you teach communication? I'm not hearing many answers from your teachers. So this is at least part of the gap, right? The things that are being taught, the things that are being learned don't always match, and there's a gap between what happens in school and what happens when you go to work. So I want to share some ideas. Again, this is not going to be a deep technical talk about different learning technologies and techniques, but I want to give you some ideas of things to think about and things to ask. So the solution, I think, in all countries at all levels is we need much better teaching and learning. 100 years ago, only small numbers of people went to universities. Now we need many people to go to universities. We need many more people with skills, and they need better skills than they needed 50 years back. How do we do that? So, one important idea is teachers need to think more carefully about what is most important. We call these threshold concepts. A threshold is the doorway that you step through when you go into a building. This is a doorway at a palace in Kerala, in fact. So the problem is often a teacher says, well, I have 15 weeks in the term. There are 30 chapters in the book. So how many chapters every week? They talk very quickly. They click through lots of slides. How much do you learn from watching all those slides? Not very much, often. Instead, the teacher should identify the most important, most difficult topics. That's what class time should focus on. I'll give you some examples. So in academic writing, 3 things that are difficult for people to understand is that academic writing always has an audience. Academic writing always refers to other texts, right? When you write a technical paper, you have to refer to other technical papers to explain what you're doing, how it improves on what other people have done. You can't just write a technical paper by yourself with no references. Similarly, in math, things like vectors, matrices, functions, these are difficult ideas for students, but until you really understand those ideas, it's very difficult to continue to higher math. So, just take 1 minute, think about a course that you teach or a course that you're taking. What is one of those threshold concepts? The thing that was really difficult to learn, once you learned it, things made much more sense. The rest of the course went much better. Okay, so think for 1 minute, talk to your neighbor. I will ask a few people to share some of these threshold concepts. I want to see if you understand the idea, if you can identify what these topics are. Okay, 2 minutes. I hope some of the ladies will have some answers this time. Or will share some answers. I know you have answers. You should be talking to your neighbors. Okay, let's hear some threshold concepts that you have encountered and I hope become experts in. This is important because as a student, you need to identify these concepts to make sure you understand them. If you try to understand every page of 30 chapters in the textbook, you can't. You need to identify what are these important concepts that I really need to understand, and what are things that you can look up on Google or ChatGPT can get you, or you can figure out later. So what are some of these very difficult but very important concepts? Louder? Calculus? What part of calculus? So calculus is a whole course. Are there one or two ideas in calculus that are especially different? Differential equations is also a whole course. Yes, I mean, there are many difficult concepts in there. Yes. Multiple integrals, just the idea of what integration does. It's easy to learn the symbols, but really understanding what it means to integrate, what it means to differentiate. Finding areas, yes. Everything else is easy, no problems.
Mesh and nodal analysis. Mesh and nodal analysis.
Nodal analysis?
Yes. I feel like the sign conventions are very confusing for me.
I think whoever decided that electrons should have a negative charge made a mistake. Physics would be much easier if electrons had positive charges. Oh well. Teachers, what do you see as threshold concepts, ideas that are very important for students but often very difficult to master?
The simple concept in the context of this conference, quite often when you teach the students about the art of measurement, only when you measure something, you will be able to kind of make a conclusion out of it. They of course do measurements in their teaching labs, but often the concept between accuracy and, let us say, precision, two very similar sounding terms, and so sometimes I ask even graduate students, what do you understand the difference between accuracy of a measurement and precision of a measurement? So quite often you find they kind of tell you the other, the meaning. It's not even mathematical, it's not even difficult thing, but it's conceptually,
Yes.
one needs to have an eye on these two parameters, because especially when somebody builds instruments which are required for strategic applications, science application, defense applications, space applications, these numbers become very, very important. It's not just what is the number that you're measuring and noting down, but what is the real value of that measurement, or what is the importance of taking multiple measurements, and how do you quantify a set of measurements with another set of measurements, is something very fundamental and very important for students who are working in that area.
Yes, good, thank you. Just the whole idea of measurement, accuracy versus precision. Okay, one more chance. Five times as loud. I'm staying in a girls' hostel. I know you can make much more noise than that.
I guess physics subject is more important. What I feel is like application of getting to know the applications of physics is important. Like doing experiments and analyzing the data of that. So we feel so boring in the class. We feel so sleepy actually.
So doing real experiments with real measurements, not just simulations. I was an engineering student. I got tired of all these classes that were just theory, so I went to the shop and learned to use saws and drills and tools because I felt like if I'm an engineer, I should be able to build things, not just talk about building things. Good, okay, so I will go on. So another thing that we need to be much more precise about is what it is that we want to learn and what it is that students should be able to do. Right? Too often, when you ask a teacher about a course, they say, oh, I will teach calculus. Or the students will learn about integration. Or students will understand for loops. But what does that mean? What does it mean to learn, to understand? We can't measure that. So instead, we should always, as teachers and as students, talk about what is it that students will be able to do. If I teach a class, if students do some activity, they should be able to define or describe something. That shows one level of understanding. They should be able to identify, they should be able to analyze, they should be able to solve problems. Right? Each of these things I would teach in a very different way. If I want you to learn a definition, I put it on a PowerPoint slide. You all copy it down, but you don't really understand. But you can recite a definition. I don't hire engineers to recite definitions. If I need a definition, I use Google. I hire engineers to solve problems, and really I hire engineers to decide when and how to solve problems. If I have to tell them what technique to use, then I can probably solve the problem myself. I want engineers and developers to come to me and say, oh, I see this problem, I think this is the way to solve it, but I have this doubt. Those are the skills that you should be practicing. Those are the skills we should be teaching, because these are the skills you will need going forward. So, here are just a bunch of different objectives about the quadratic formula, right? The student should be able to write the formula. Is that important? No, you can always look up the formula. They should be able to explain the importance. They should be able to solve equations and solve problems. Probably more useful, although I'm sure you could type a formula, you could type the equation into Google, Google would solve the equation for you. They should be able to decide whether to use the formula. They should be able to describe the history. They should be able to derive the formula. So one concept, quadratic formula, but 6 different things that I might want students to be able to do, and I would teach these different things in very different ways. And the questions I would ask on a homework or an exam would be very different depending on which of these I wanted you to do. So by being more precise, it helps teachers know what to do, it helps students know what to learn, it helps both teachers and students know what is likely to happen on a homework, on an exam. So, which of these is more useful? Reciting a definition or being able to restate the definition in your own words? Restate, why? I can memorize a definition in Telugu, and I don't speak Telugu. But Sanjay Kode could sit me down and teach me all of the sounds. Would I understand the definition? No. Would I be able to use it? No. But if I can explain it to someone else in my own words, I understand it much more. What about the difference between I give you a set of categories and you put things into those categories, and I give you many examples and you have to choose the categories and then sort them? Which is more useful? Organize into categories that I provide, or create your own categories? Ah.
So you can ask. I'm sure they will be able to tell you. What is the difference between machine learning and deep learning? That's exactly what you're asking.
Does that make sense? Maybe. Okay, last one. Decide if a proof is correct or write a proof yourself. These answers may be very different in 20 years when all of these generative AI tools are better, but both of these are important in different times. Probably writing a correct proof is more difficult than looking at a proof, looking at a program, and judging correctness. Again, I want you to be thinking about what specific things should students be able to do as a result of learning. How many people have heard of Bloom's taxonomy? A few? Okay. So this is a way of categorizing different things you might ask someone to do. The very lowest levels are remember and understand. Asking students to define, list, recite, label, translate, convert, indicate. These are the sorts of questions we often see on exams, yes? How often is an engineer, a software developer, a manager asked to do these things? Will your manager call you into their office and say, please define this term for me? No. Much more useful is being able to apply and analyze ideas. Calculate, solve, classify, operate, categorize, classify, derive, model. These show much more mastery, much deeper understanding, much greater skill. Top two levels, evaluate and create. Critique, justify, recommend, improve, construct. Again, this is the work engineers should be doing. If I hire an engineer and all they can do is define and convert and label, that's not an engineer's work. If I hire an engineer, if I hire a software developer, they need to be able to critique, recommend, improve. These are the skills that you need to practice. So, how much time in class are you learning those skills? Lots? Not very much. Too often in class, we're down here at understand and remember. As teachers, we should always be trying to move higher in this taxonomy. Yes, there are some things students need to be able to define and explain before they can calculate and classify. But if all we're doing is down at the low level, that's not good for the students, it's not good for society. The more we can do to have people working at these higher levels, the better. So I keep asking, do you learn to do these things in your classes? Do you teach these things in your classes? So I want you to think about how we learn other things. If you were learning to play football, would you sit and read a book about football? No? You would listen to someone give you a lecture about football. That would be a good way to learn football, yes? No? I'm confused. If you wanted to learn to play a musical instrument, you would read books about the instrument? No? Exactly. You don't learn to ride a bicycle by watching YouTube.
Then you can ride a cycle. Same thing in classes also. Same thing in things also.
How do you learn to play music? How do you learn to play a sport? How do you learn to ride the bicycle? You practice. We should practice things we want to get better at. See, you do know the answers. It's not just practice, you need a coach to help you. Right? When you learn to play football, yes, some of the time you just play football, but you also have a coach that has thought about the different skills and helps you practice each of those skills. When you learn to play a musical instrument, when you learn to dance, the same thing. You play real music, but you also play short pieces of music designed just to help you practice skills. How to move your fingers quickly. So I want to suggest education at a university should be the same thing. If I want students to be able to design, analyze, I should be creating experiences to help them practice those skills when I can be there to watch and give feedback. Right? The person that leads the music ensemble, the football coach, doesn't say, well, I gave you some things to do, now I'm going to go back to my office, try to learn all this by yourself. Right? The coach watches and says, oh, that was good, keep doing that. Oh, that wasn't as good, try changing it. That's what teachers should be doing. So I think I'll skip that one. So there are actually people that study education, what are the best ways to learn. The worst way to learn is to be passive, to sit while someone talks at you, staring at them, as many of you are doing right now. A better way to learn is to be active, is to be doing something. Taking notes, moving around. Even if I just every minute made you stand up and sit down, you would be more awake, you would remember more. But we can do much, much better. You really understand when you interact with other people and discover ideas for yourself. I'm sure all of you have had an experience studying for an exam, you talk to your friends, you understand a little bit, you explain it to your friend, they understand a little bit, they explain it back to you. It's that conversation, when you figure it out yourself, it's so important you're going to get it from the back and the front. That's when you will really, really, really understand. So this is called the ICAP model: interact, construct, active, passive. So on the teacher side, the traditional model is the sage on the stage. I'm here, I have lots of PowerPoint slides, I click, click, click. I talk very fast because I'm trying to get through 34 chapters in 24. Much better is to be a guide on the side. If I'm talking to my students, if I'm listening, I see where they have trouble, I can help them. I see where my explanation didn't make sense, I know what to do better. Every day that I'm teaching, I want to be learning how to be a better teacher. If I just click through a bunch of PowerPoint slides, I already know my PowerPoint slides. I don't learn anything, and I don't know what makes sense and what doesn't make sense. If I'm listening to my students and walking around having conversations, at the end of every class, I have ideas for making the class better. So in the US, people raise sheep for the hair, for the meat, for the milk, and they often use dogs to keep the sheep out of trouble. What do you think happens if the dog runs up to the sheep? The sheep all run away. So the dog has to be very careful. He takes a step, he watches the sheep, he takes another step. That's what I try to do as a teacher. I try to be close enough to hear what is happening, to know when there's a problem, to offer help, but not so close that the students all stop talking and wait for me to leave. So there are many different techniques. I've spent some time the last 2 weeks working with faculty at VNR on some of these. Project-based learning, problem-based learning, peer-led team learning, peer instruction, inquiry learning. Professors who study education have developed ways that help students learn based on research. We need to be using more of those techniques everywhere. US, Africa, India, Vietnam, everywhere I've been, we need to understand these techniques better and use them more. So, here's the summary. If we're more clear about what we want to learn, what are the concepts, what are the objectives, then we can adopt better teaching techniques, which will lead to better learning. Students will interact and construct more. That will help them. What does that mean? It means we'll have graduates that are better prepared for better jobs, which means we'll have a better workforce to explore all of these amazing technologies we're hearing about, which hopefully means we'll have a better world, a better society. Our lives will be better and happier. Oops. And a better society should lead to better teaching and learning. So, a final set of suggestions. Students, don't worry so much about marks, your rank in the class. Think about where you want to be in 10 or 20 or 30 years. What are the skills you want? What are the experiences you want? Think about how you learn. Think about what works for you and your friends. If you know what helps you and you know what doesn't help you, then you can become a better learner. And the reality is you will all be learning for the rest of your life. I got a bachelor's degree in computer science. I got a master's degree in computer science. I got a PhD in computer science. Every class I have taught was a class I never had as a student. The programming languages have changed, the concepts have changed. Neural networks, no one had heard of neural networks when I was in school. So if you want to work for more than 2 years, you need to be able to learn new concepts, new technologies, new approaches on your own all the time, which is actually really, really fun. So that's good. Teachers, many teachers were never trained to be teachers. They were trained in their content. Teachers should be learning what good practices are for teaching and experimenting continually with students. Try things, see what works, see what doesn't work, make it better, and especially find other people with similar interests. I can't change an entire course by myself, but if I find 4 other people that teach the same thing, together we can make some really good changes. Finally, if we have any leaders, administrators, directors, principals, you too should know what the research says about teaching and learning. I think many of those people don't know that. Then you should be supporting your faculty so they can learn these techniques and use them in their classes. And you need to change the rooms where you teach. It's very hard to work as a team when you're all in chairs that are bolted to the floor, staring in one direction. It's very hard for me to talk to all of my students when I can only get to an aisle there and an aisle there. There's no way for me to talk to the people in the middle. So we need to change lecture halls, we need to change laboratories to do this better. Okay, I'm not sure when I was supposed to stop, but I think this is probably a good place to stop. I would love to hear some questions or comments or ideas from anyone that's here.
I have a question, sir.
Yes.
Here, the passive group.
Ah, there you go.
So I'm Gopichand, I'm a recent graduate myself. One of the favorite side that I liked is about students, where you emphasized on students shouldn't be caring about ranks or marks, rather than they should be focusing on the concepts. And you also said regarding the leaders, administrations and teachings, you said like more emphasis should be given to the teaching, how do you upgrade the facilities. But I would say most people actually know that point. I mean, when I was in class 8, my physics teacher, there we used to have something called regarding combustion. What's called combustion? I'm a mechanical engineer myself. He says he brought a candle, he put the conical flask and said combustion is something what happens in the presence of oxygen. You see, I'm using this conical flask. There is no air, oxygen, so the combustion stops. This is how he actually defined. So coming to the point, if I ask the entire people in this conference, saying how many of you really agree that conceptual learning is really important? If I ask that question, how many of you agree that conceptual learning is really important? The obvious choice is every teacher, every student will definitely raise their hand. But is it any sort of the psychological thing that, you know, most people are aware of many things, but why isn't that thing is into putting into practice? Meaning, I mean, we have labs, we have classrooms. The whole point of engineering is you learn something in concepts in classrooms, you want to put that into execution through lab or something like that. But why isn't the practicality isn't happening? I mean, labs are like, I mean, because you gave talks with a lot of you discuss with a lot of people. In terms of theory wise, in terms of awareness of all the things that what you have said, people are aware of it. But why isn't still putting into practice? That's my question.
Good question.
Yeah. Thank you. Sorry for the lengthy question.
No. Well, I mean, we also know that it's dangerous to ride two-wheelers in the city, and it's dangerous not to wear seatbelts, and it's dangerous to drink alcohol, and yet we do many of those things. I think in education, some of it is tradition, right? How was I taught? Mostly lecture. So I become a teacher, I mostly lecture. I think part of it is it's easier to lecture often, right? I can get a deck of slides from the company that wrote the textbook. I can change the name, I can add a few details. Designing a good learning activity takes work, it takes time, it takes resources. So, many things. But yes, I mean, you're right. I think many people are aware that there's a problem. It's how do we move to solve it?
Is there anything that psychologically that can be done so that theoretical thing can actually be put into practice?
I don't know. That's a good question.
Okay.
Anyone? Or other questions?
So I am always available. I have got 35 years of real manufacturing experience in all the fields like development, manufacturing, marketing, exports, quality control, whatever you say I have. I'm ready to train them in all those respects. I always welcome all the students to come to me
Good.
to improve your skills, to upgrade your professional skills, to improve your better life.
So my last comment, I think we need to continue. I think often academia and industry do not talk enough. I think there needs to be more communication, more understanding, both ways. So thank you very much. I hope you thought some. I hope you have some new ideas. And I hope to be able to talk with more of you in the next few days. Thank you very much.
Sanjay ma'am wants to say something.
Do we have another mic? Oh, there's a mic here. There's a mic right here.
So interesting questions, and I was really surprised to see the very, very passive girls, and when the challenge was thrown open, also there's still passiveness. And to address one of your questions is, do we practice enough speaking within the classroom? We speak a lot outside the classroom. But do we know how to speak about the topics, to discuss within the classroom, raise questions? Because I've seen many classrooms, and this is why after many years in industry, I devoted the last 15 plus years to better teaching and learning, and Clif has been coming here to ENR, training teachers. And we have been doing a lot of teaching, learning, and you also need to be pushed back. You know about wit and will? Are you students of VNR? How many are here students of VNR? What year? First year. Okay. So you need to go into every class asking why I'm learning what I'm learning. And then if you come out with the answer, then you're so much better off. And the teacher is expected to be doing why I'm teaching what I'm teaching. So there's a lot of platforms here at VNR, more than you can imagine. So you're in the first year, you're in good shape because you have the next few years to really shape your life and career and do all of the things that Clif talked about, be on the other side, right? Are you going to do that? It's not just your job to just be passive. You can push your faculty members and say, Why am I learning what I'm learning? So together you can get the answers. Do you get me?
Say yes.
Oh my God. You have to, if that's what your teacher has to tell you to do, problem, right? So there are many methods, group-based learning and others, where the teacher walks around. So encourage the faculty, all faculty, to be walking around and seeing what your class does. Get the pulse of your class. And when that happens, I can assure you there will be a change. And learn to learn. There are many, many, many concepts. There are problem statements in every slide that Clif put up. I'm sure you have 100 things to do. All the best. Thank you.